Okay, part 2 of the homework. So let's go to the next one, number 11. Let's see what number 11 looks like. Alright. So now you're kind of getting an idea, hopefully, you're kind of getting an idea of how to solve these things. Basically, you're trying to get the same base, if it's possible. And it should be possible, because almost all of these on this particular lesson are kind of rigged so that you can get the same base. Alright, so there's your problem right there. Let's take a look at the numbers. Look at the bases, okay? I got a 2 here. Now this is a 1/8, but I also realize there's an 8 there. So what do you think I can do? Maybe change this to what? Change this to 8 or change this to 8? Yeah, I could change it to an 8, but then it would be 8 to the negative first. But then, what about the 8 itself? What base can I get both of these to be the same? 2, right, because this is what? 2 to the third, right? And again, there's a couple ways you could go about this. I would just keep this the same. And you could do it a couple ways. You could do this. 8 is the same thing as 1 over 2 cubed. Do you agree? And you're like, well, wait a minute. That's still not the same base. Yeah, but it's pretty close, though, isn't it? So what can we do? We can take this, flip it to the top. But if we flip it to the top, what do we have to change? The sign of the exponent, correct? Now look what we've done. We've got the base to be the same. So it just took a little manipulation, just a little bit of, I don't know, trickery. It's not really trickery, but you get the idea. So you got the base is the same. So what do you do with the exponents? Negative x equals negative 3. Divide both sides by a negative, and so x is 3. That's all there is to it. The hardest part is this, is trying to get them to be the same base and get to this right there. Once you get to that, that's really simple. All right, but getting to that, that's the part that's a little bit tough. All right, let's try number 12. Let's just put it up here. Ooh, look at this crazy thing. 4 to the 8 minus 2x equals 256. How about that number again? Well, look what I have. I got a base of 4 already, and I got a base of 256. Do you think there's any way to write 256 like 4 to some power? 4 to the third? Is that what it was before? 4 to the fourth, right. That's what we did, isn't it? 4 to the fourth. And if you don't remember, actually I had it right there, didn't I? Didn't need to do it again. Yeah, 4 to the fourth. So that one was actually kind of easy, wasn't it? It didn't take a whole lot of thought, because we had already done that number before. But if you didn't remember that, you're looking at this and you're saying, hey, wait a minute, I got a base of 4 here, and I got a 256. Is there any way to write 256 so that it's a base of 4? So what do you go to? Go to the calculator, for goodness sakes, all right? And then punch in 4 to this, 4 to that, and try numbers until you get 256. If you don't, maybe you had to change something else. Maybe you could have changed the bases to 2 to a certain power or whatever, all right? So this is 4 to the 8 minus 2x equals, and this is 4 to the fourth. The bases are the same, so you set the exponents equal to each other. So 8 minus 2x equals 4. And now you just do some regular old math. Let's see. Add a 2x to this side, subtract a 4 from this side, divide by 2, x is 2. Okay, that part from here down is simple. It's this part right there. That was the part. Actually, this part right here. Changing 256 to 4 to the fourth. That was probably the hardest part of that whole entire problem. That's the part where it took a little bit of thought, a little bit of ingenuity. Not much on that one, but let's do another one. Having fun yet? These are pretty cool. I like doing these. This one's pretty much the same. It's just different numbers. So you should be able to do this one. In fact, let me give you about 30 seconds to work on this. Okay? You're on 30 seconds. Okay, it seems like most of you are kind of finished up with that. What's the first thing we need to do? Change the bases so that they're the same, correct? So this has a base of 2. Let's change this. Kind of did this in 2 problems before, right? Instead of 1 over 4, how do you think we're going to write this? 1 over what? 2 squared. Good. And then let's take that 1 over 2 squared, flip it so it's in the numerator. So watch, this is going to be 2 to the 7 minus 3x equals right? That's over 1, right? So what are you going to do? You're going to flip that to the top and change the sign of the exponent, right? It's nothing new. We did this, I think, 2 problems ago. We did that little thing right there. Got the bases the same now, so we set the exponents equal to each other. We'll do this very quickly. So add a 3x to both sides, add a 2 to both sides, and x is 3. That's all there is to it. Nothing new on that one. It was just a little extra practice. All right, this next one though is a little bit different, so we might need a little different technique for this. Let's go this pink again. I got 36 equals b to the 2/3. Now this is a little different, okay? This is not the same techniques as what we did before. This is not really getting the bases to be the same. Because really, if you look at it, is there any way I could get the bases to be the same? Nah, because that's a b. This time, the base is what we're solving for, okay? On the other problems that we've done today, what we were solving for was always the exponent. So this is a little different. So what I want to do is I want to get b by itself. So I need to get rid of this 2/3. Now watch very carefully on how I do this. I'm not going to go through some big explanation. I'll just show you how to do it, and you tell me if that works or not. I want this to be b to the first. So what I'm going to do is I'm going to multiply this by something that turns it into a 1. What can I multiply this by in order to get it to be a 1? Not 1/3. That's not going to get that to be a 1 because 2/3 times 1/3 would be 2/9. 0? Yeah, 0 technically would work. I'm trying to think of, but then if I took this to the 0 power and I took this to the 0 power, everything's going to be a 1 and I can't do anything. I can't get b by itself. I heard it. 3/2, right? Take it to the 3/2. Look what happens. That cancels, that cancels. I can't just do that, though, to one side, can I? What am I going to have to do? I got to do it to the other side, too. So I've got to take that to the 3/2 power. So that's a 1, right? They cancel out. So I've got 36 to the 3/2 power. And now I just have to figure that out. We've actually done that before. Did that earlier in the year. Remember this? It's the same thing as 36 to the 1/2 to the 3rd. When you agree that's the same thing? We did that earlier in the year. Do you remember doing that stuff? Okay, you take it to the 1 over the denominator, and then you can take it to the numerator. Again, they've rigged these, haven't they? Okay, they just didn't throw a random 36 in there. Okay, they put something in there that you could take the square root of. Because 36 to the 1/2 is the same thing as the square root of 36. Square root of 36 is 6. But then you got to take that to the 3rd, and then 6 to the 3rd is whatever it is. What is it? 216? Now, they said plus or minus, didn't they? Right, because since this is to the, watch this. This is b to the 2/3, which is the same thing as b to the 1/3 squared. So b could be a positive value or it could be a negative value, couldn't it? Because if I take it to the 1/3 of the cube root, I'm allowed to take the cube root of a negative, and I'm allowed to take the cube root of a positive. So that's why it's both. If you just want to put positive, that's fine. Okay, I'm not gonna mark off if you don't put the negative part of that. Just put 216. You're good to go. But technically, yeah, you could put either one of those in there. All right, we're getting there. 2 more, right? This is pretty much the same thing. I'll go through a little faster on this one, since we pretty much just did one like that. Okay, right. All right, so here's the same deal. A to the 3/4. I got to get a by itself, so I get rid of the exponent by not multiplying, but taking it to the 4/3 power. So that means I'm going to have to come over here and take that to the 4/3 power. That cancels out to be a 1, a to the 1st, equals, and what's this? This is 125 to the what? to the 1/3. Take it to the denominator first, to the 1 over the denominator first. Now you could go 125 to the 4th power, but you're going to get some gigantic number, and then you got to take the cube root of some gigantic number. It's a little easier if you go 125 to the 1/3, and then take that to the 4th power. So 125 to the 1/3, that's the cube root. I think it's a 5, isn't it? 5 times 5 times 5? Yep, it's 125. So you can do that in your head. And then that means 5 to the 4th, and that comes out to 625 if you put that into a calculator. And that's what A is equal to. All right, pretty much the same as the one we just finished doing. All right, we got time to do one more. I'll do it up here. I'll do it quickly because time is running out in our class. And that's 3/5 to the x plus 1. All right. Look, I got the same. Actually, it's x minus 1, isn't it? It's not the same. What I need to do is get the same denominator, or the same bases, I'm sorry. Well, I'm running out of time, so let's just do this very quickly. 25 over 9. 25 over 9, I could go 5 squared over 3 squared. Would you agree? And that equals x plus 1. Watch this. These are both squared, so I could go 5 over 3 to the 2 times x plus 1. All right? And now, the bases aren't the same, but what can I do with this? I can flip it, and that'll be 3/5, but then I got to change the sign of this stuff up here. So it'd be -2 times x plus 1 equals 3/5 to the x minus 1. The bases are the same, so what do I do with those two exponents? Set them equal to each other, solve for x, and you get -1/3. All right? Why don't you just hang on to those and finish them up? If you didn't quite finish in class, finish them up, and I'll collect it tomorrow, and then we'll do logarithms tomorrow.